Hello everyone, welcome back to our channel Chemistry Made Simple for NEET, and this is Dr. Radha Subramaniam with you, and today we are going to start the session solid state from chemistry NCERT, and I have divided this unit into 7 parts, and we'll be going through the first part today. And before starting with the concepts today, I'd just like to reply to a few questions some of the students had asked to me regarding the NEET exam. So the first question is NTA providing free coaching to the students? So as of now, NTA is providing only free mock test to the students in Test Practice Center, that is TPC, and the same facility is also available on website www.nta.ac.in and NTA student app. Initially one mock test was available for the exam, and the numbers will be gradually increased. Okay, another question is, can candidates change their test practice center TPC preferences after final submission of registration? So there is no facility as such to change the test practice center preferences after final submission of registration. Candidates may get any of TPC out of the 5 preferences, or in some cases other than out of the choice offered. Okay, now another question is, how candidates will know about the test date and slot of the test practice center? So the candidates will receive the date and slot for practice at TPC through SMS or registered email ID 24 to 48 hours before the scheduled slot in TPC. The same SMS will be used for entry at the center. Okay, with that we will start with today's session, and firstly we will learn about different types of solids, and you might have all heard about amorphous and crystalline solids. So solids can be classified as crystalline or amorphous on the basis of the nature of order present in the arrangement of their constituent particles. That is, a crystalline solid is usually having a large number of small crystals, like salt crystals and all that, and each of them will have definite characteristic geometrical shape. Whereas in a crystal, normally the arrangement of particles, whatever it is, atoms, molecules, or whatever it is ordered, and it has long range order, which means that a regular pattern is followed for the arrangement of particles, which repeats itself periodically over the entire crystal. So hope it is clear regarding what is meant by crystal. Okay, now we have got something known as polar molecular solids, which is some solids, substances of like HClSO2, that is the molecules of HClSO2, they are all formed by polar covalent bonds. That is what is the speciality for that? The molecules in such solids, they are held together by strong dipole-dipole interactions. So these solids will be strong, very soft, and they are non-conductors of electricity. Their melting points are higher than those of non-polar molecular solids, but most of them will be gases or liquids under room temperature and pressure, that is like SO2. So polar molecular solids, understood? So mostly they will be asking like HClSO2. These are all examples of polar molecular solids. Okay, next we were talking about amorphous solids. You have just seen like talcum powder and all that, very soft, and it's irregular in shape, and arrangement of constituent particles like atoms, molecules, ions, and all that. In such a solid, they are having only short range order. See the figure here, over here, two-dimensional structure like quartz and quartz glass are given here, and these kind of arrangement regular and periodically repeated. See, the same pattern is getting repeated, but it is seen over a short, very short distance only, and these portions are scattered, and in between arrangement will be disordered. See, this is bigger one and this is smaller one, like it's scattered all over. Clear? All of you understood? Now next we will move on to molecular solids, and the molecular solids are mainly divided into non-polar molecular solids. Polar molecular solids are hydrogen bonded molecular solids. What is meant by non-polar molecular solids? See, these are very soft and non-conductors. They don't conduct electricity, and their boiling points are very low, and usually they are liquid or gas at room temperature and pressure, and they are held together by weak van der Waals force or London forces. Okay, now coming on to classification of crystalline solids. Crystalline solids are divided into molecular, ionic, metallic, and covalent solids. depending on the nature of the intermolecular forces. You can see the diagrams over here, and there are 4 types of crystalline solids in the figure. Okay, now next you have to learn or know the property of each, like the shape. For crystalline solid they are having definite geometrical shape, whereas for amorphous it is irregular. Melting point, so here for crystalline they melt at sharp and characteristic temperature, whereas amorphous they soften over a range of temperature. And cleavage property, see, if you cut the crystalline solid with a sharp edged tool, they will split into 2 pieces, and newly formed surfaces are plain and smooth, whereas amorphous solid, if they are cut into pieces, it will be irregular surface. And heat of fusion, for crystalline solids they have definite and characteristic heat of fusion. Amorphous solid do not have definite heat of fusion. Then anisotropy, anisotropic in nature, whereas this one is isotropic in nature, amorphous. Then nature, it is true solids, and pseudo solids are super cool liquids. The order in arrangement of particles, long range, and this is only short range. Okay, just read it properly and revise it thoroughly. Okay, now we were saying that crystalline solids are anisotropic in nature, that is many physical properties like electrical resistance, refractive index and all that, they show different values if you measure it along different directions in the same crystal. See, if you take the same crystal and then measure from different directions, then the physical properties will show different values. That is what we call as anisotropic properties. And why it is happening? Because the difference in arrangement of particles in different direction. So because of the different arrangement of particles along different directions, some physical property values is found to be different along each direction. And amorphous solids, they are isotropic in nature because there is no long range order in them, and arrangement is irregular along all directions. You can see refer to the diagram given here. And crystal solids have sharp melting point. Amorphous solids will soften over a wide range of temperature. They can be molded and blown into various shapes, and when you heat it they become crystalline at some temperature. And some glass objects from ancient civilizations are found to become milky in appearance because of crystallization. The amorphous solids have tendency to flow, because of that they are called pseudo or supercooled liquids. Okay, now what are the general characteristics of solids? Mass, definite, volume, shape and all are definite. Intermolecular distances are very short. What are intermolecular distances? The distance between molecules, they are very short. And intermolecular forces, because they are very close to each other, they are very strong. Forces are very strong. And whatever constituent particles like atom, molecules, ion, they are having fixed positions. You can see they are arranged in fixed positions, and they can oscillate only from their mean position, and they are incompressible and rigid. You cannot compress it, they are very rigid. Okay, now hydrogen bonded molecular solids. See, molecules of various solids, they have polar covalent bonds between hydrogen and fluorine, or oxygen or nitrogen. And strong hydrogen bonding will bind molecules of solids like water in ice and all that, and non-conductors of electricity. They are volatile, become vapors easily, and they are soft solids under room temperature and pressure. Okay, now we will see about the characteristics of a unit lattice. How can you characterize a unit lattice? Firstly, its dimension along 3 edges A, B and C, and these edges can be or cannot be perpendicular to each other. And the angle between the edges, alpha, that is between B and C, and beta between A and C, and gamma between A and B. So a unit cell is characterized by 6 parameters, that is A, B, C, alpha, beta and gamma. Okay, these are all very important concepts. On the long run you will have to do sums and so many things based on this, and I will be uploading some sums based on all these concepts. Okay, with that we are coming to a close of the part 1 of this session, and I will be soon uploading the next parts one by one. And as you all know, talks are being there whether the exams are being postponed or not, but whatever the case may be, I think that it's better you revise everything well in advance and be prepared to do the exams. Let it come whatever, whichever date it may, but you should all be well prepared for the exams. And do subscribe, share and like to the like my channel, and also share it with your friends, and don't forget to press the bell icon, because as soon as I put new videos, you will be getting the post notifications immediately. I will be soon uploading another good video at the earliest, and thanks for watching my channel.